All right, today we're going to be looking at a part one introduction into how to visualize data using tables and graphs. We're going to look at a couple different types of basic graphs and tables, such as pie charts, dot plots, and the like. But before we get into that, we want to make one important distinction between two types of data. So, data in general, we can classify them into two categories: a quantitative and qualitative data. Now, the main difference between the two is quantitative data has numbers that measure some kind of amount. So, usually it will be a numerical value that has context. So, for example, any kind of temperature, or maybe a measurement of length, height, weight, and so on would be quantitative data. Meanwhile, qualitative data, which is also sometimes called categorical data, is data that is either A, not measured using numbers, or B, numbers that do not have a numerical relationship. So the first one is a little more straightforward. Any type of kind of question, such as maybe in a survey, who are you voting for in the local elections, or you type in the name of a candidate, or you get asked your favorite kind of ice cream. Those types of answers would create non-numerical data, and so that would be classified as categorical data. Now, the second one is a little more difficult to understand. Sometimes we have data represented by numbers that do not have a numerical relationship, like height and weight. So a good example of this, you'll see it in the example here as well, but things like that measure time, like dates, for example. Dates may measure using numbers. However, those numbers don't have a magnitude. For example, 1 is January, 2 is February, but that doesn't mean 2 is bigger than 1. That doesn't really make any sense. Another example of this is when we split people into groups and we say, hey, you're group 1, you're group 2, you're group 3. But that doesn't necessarily mean that 3 is bigger or better than 1. They're just numbers used to represent the different types of groups. And so if we look at a couple different examples and see where each one, which category each one falls into. Let's start with the first one: a basketball team's points in every game of their season. That would be an example of quantitative data. You could score 60 points, 75 points, and those numbers can relate to each other. That 75 is bigger than that 60. A list of every student's favorite color. So responses to that would be blue, green, red, purple. Those aren't numbers, those are categorical. The blood pressure of 100 patients at a hospital. That would also be an example of a quantitative data. You get numbers like 120, 125, 107, things like that. You can connect those different numbers and come up with relationships between them. Next year, we have the day of the month that 200 random people were born on. So these numbers would range from 1 to 31. But when we collect the data, we wouldn't go and say, 17 is somehow bigger than 2, although it is. That doesn't really mean anything in the context of whatever we're looking at. We're just looking at the day of the month that people were born on. So that would not be quantitative, although we will have numbers as data. That will be a categorical data. And lastly, high temperature of each day in New York City in 2007. Kind of used this as an example earlier. That will also be quantitative. Now let's start by looking at some kinds of graphs that we can create with categorical data because it might be a little easier to work with at first. So on the left here, we have a data set that I've pulled, and there's no context. It says data on degree of wear. The context isn't really important for this exercise, but we can make up something. Let's say the degree of wear of the favorite book you've ever read. That would make sense here. You see we have some, maybe your book was slightly worn, moderately worn, or heavily worn. Some of us haven't read books in years, and so we might not know what the wear of the book is at this point in time. And so we're going to start with a simple type of graph, a bar graph. And what a bar graph does is it measures the counts of each observation we see in the set of data. And so I'll start by drawing the basic axis here. And so we see we have a bunch of different responses to this, such as unknown, slight, moderate, and these can all be broken into categories, which we can then measure how many times we see that observation or that particular value using bars. And so, for instance, our first bar we might use as slight, as in slight wear. And on the x-axis here, we'll have all of the different categories, and on the y-axis, we'll have what is called the count. And this is sometimes called the frequency also. They mean the same thing. It measures how many times we see that value in the data set. And I'll put little tick marks here to represent the number of times we see each one. So we'll start at 1 and go up to 5. And so let's start with slight here. We see that there's one observation right there, one observation right there, and then 2 more in the second column over at the top. And so we have 4 slights. And so we would then draw a bar going up to 4. And we can shade it in too, if you please. Okay, and so that would be the bar for slight. And then we would go to the next category that we see. So maybe we'd want to use light and moderate. And because that's quite long, I'll shorten that to LM. And we can see in our little chart here that there are 2 light moderates. And so draw this bar up to 2. And then we can repeat the same for moderate. And then do the same for moderate heavy, which I would denote MH. I'm gonna have to draw this out a little more. And then we have heavy and unworn and unknown. And so I'll fill in these as well just to complete the bar graph. For moderate, it looks like we have 3 observations. And for moderate heavy, we have just 1. For heavy, we have also just 1. For unworn, we have, it looks like 2. And lastly, for unknown, it looks like we have 5. So this one will go all the way to the very top. And that's our bar chart. And in this case, there was kind of a method to which I placed the order of the bars. Here we have kind of a range of wearness going from slight, the least worn, up to heavy. And then we have kind of two exceptions to the rule, unworn and unknown. And a good check for whenever you're doing a bar graph with not too many data points is to count the number of data values you have in your chart and compare that to how many you have in the bar graph to make sure that you haven't missed any, you don't have any incorrect counts. So here, it looks like in the data set we have 18 values, 9 in each column, and in our bar graph we have 4 plus 2 plus 3 plus 1 plus 1 plus 2 plus 5, and so that gives us 13 plus 5, which is 18. So it looks like we've gotten all the correct values here. Now a dot plot is very similar to a bar chart. And it's going to look pretty much the exact same shape. A dot plot gives the same relationships that a bar chart does, except instead of using physical bars, we use charts, or not charts, but dots or some kind of picture to represent each individual count. So for instance, on the x-axis, we'll still have the same categories. So here, for instance, we'll have slight first, and this time instead to represent the count of 4, we'll do for each individual slight that we see in the data, we'll put some kind of marking, either a dot or an X. So I'll do an X because that's easy enough. And because there's 4 of them, there will be 4 X's going up. And then we can repeat this process for LM and so on, LM and moderate. I won't go the whole way this time. LM, because we have a frequency of 2, we'll draw 2 X's. And you always, with these dot plots, you want to make sure that your X's are all the same size so that you can compare the heights of each stack of X's to each other correctly. And moderate, we had a frequency of 3, and so we'll draw 3 X's going up. And here we can see another way of representing that. In general, more books were slightly worn than moderately worn, and the smallest here, at least of the 3 that we've drawn in the dot plot, is lightly moderately worn. Now, moving on to a pie chart. A pie chart is a little bit different. It looks much different from the last 2. With the pie chart, you've probably seen this a lot in newspapers or online. It's a very common way to visualize percentages, where they take kind of a slice of a circle and give you the percentage. You can kind of see which category has the biggest percentage of all of the observations. And so that's exactly what it does. And in order to make one, we'll have to calculate each category as a percentage of the total. So for instance, with our data set here, we saw that there were 18 total observations. And for slightly worn books, we had a count of 4. So 4 out of those 18 were slightly worn. And so to get that percentage, we can take the part and divide by the whole. 4 divided by 18, that's about 22-ish%, roughly. I'm not going to have the exact calculations here, but that would give us the percent that is slightly worn. And so if we draw our pie chart, it's going to take the form of a circle. And what we'll want to do is cut a slice out of that pie that is about 22%. So if we think about how big a quarter is, it's going to be a little less than a quarter. And so maybe it'll be something like that. And this slice of the pie chart will represent slightly worn books. And we can repeat this process for the other categories. And so the next one we could do is lightly, moderately worn, which was 2 out of 18, or about 11-ish%. So that one will be about half the size, or it should be exactly half the size of this first slice. So maybe it'll go to here. And so that gives us that. And moderately worn was about 3 out of 18, or 1/6 of the total. And those three together would make up 9 out of 18, or half the pie. So here we can draw this as moderate. That's about 3 out of 18. Here's LM. This is obviously not drawn perfectly because this slight wedge here should be a little bit larger than the moderate wedge. But if we continue, moderately heavy and heavy both had just one observation, so they would be just 1 out of 18, and that would be a very small part of this pie chart, this a very thin amount for each one. Here we have MH, and here we have our heavy. And then unworn had 2, so it'll be about, again, about 2 out of 18, or 11%, something like that. And unknown has a count of 5, and so that will make up the rest of the pie chart because there were no more categories. 5 out of 18, and as we would expect, its slice is the biggest of all the slices in the pie chart as it has the biggest count. Now, early on in your statistics class, you might come across a histogram, and you'll see pictures of them and they'll look almost exactly like bar charts, and you're going to wonder, well, what exactly is the difference? And there is a distinction between the two. You can't, a lot of people use them interchangeably, but you really want to avoid that if you can. There is a slight distinction between the two. And so I have them outlined down here at the bottom. But there's 2 key differences, and that is the type of data they use and the placement of tick marks on the graph. So first big difference, bar chart uses qualitative data or categorical, while a histogram uses quantitative data always. So bar chart will use categorical, histogram quantitative. And when we draw them, they'll also look just a tiny bit different. So if you recall, when we made the bar chart, I split them up into different bars and categories, but you'll see that I left some space between each bar. And that's kind of to highlight the fact that these are totally separate values. You can't compare one to the other numerically. They're not connected in that sense. And so we see that a bar chart will have bars like so, split up. Whereas in a histogram, we'll have the exact same thing. So notice on the y-axis of the bar chart, we measure the count, and that will actually be the exact same. Histograms also measure the count on the y-axis, and in fact the x-axis is very similar too, in that we'll be drawing bars that represent the number of each different possible data value that we see in the data set. But where the difference comes is where each category here, each bar represents some kind of a qualitative value, such as a color, perhaps green, blue, and so on. Bars in a histogram will be packed right together with no separation in between them. And not only that, each bar in the histogram, because it's quantitative data, will usually represent a range of numbers that we see. So for instance, if we go back to a temperature example, say the daily temperature in some city for every day, those numbers will range widely throughout the year. Let's say this is a pretty climate-controlled place. The numbers range from 50 degrees to 75 degrees Fahrenheit. So in this case, we might make a histogram that goes from 50 all the way to 75, but we are not just collecting all of one particular value to represent each bar. We might say look for all the values, all the temperatures from 50 to 55 degrees and put those as a count and then record that on our histogram. And then we might take all of the temperatures that go from 55 to 60 and do the same thing. And from 60 to 65, and from 65 to 70, and lastly from 70 to 75. We'll combine all of those, record the count in each interval, and then put that on the histogram. And the reason we do that is because we don't want to make a histogram with, in this case, it would be 25 different bars, but sometimes it could be, end up being hundreds of bars depending on your data set, and that's just not an efficient way to make a histogram. You kind of lose the pattern. We just want to see the general pattern of the data. And so here in this made-up example, we can see that, not a lot of days were 65 to 70 degrees for some reason. And we can, make conclusions based on what we see in the histogram. And when I mentioned the placement of the tick marks, I was referring to on the x-axis, where with bar charts, we label each bar right below in the center of the bar here. You can see it's going right in the center. Here, our labels on the x-axis are actually in between the bars, as you can see. And that's because we want to display the fact that the bar represents numbers that are bigger than 50, but less than 55, and bigger than 55, but less than 60, and so on and so forth. And later, you'll see many more examples of histograms, but that's a basic summary of the differences between them for now. One last plot that I want to show for now, also relating to quantitative data, is a stem and leaf plot. And this one is not so much represented by pictures as our bar chart and histogram, but it's another way of showing kind of the pattern of the data. And so what we do with a stem and leaf plot is we draw a big vertical line down somewhere on our paper. Here on the right, by the way, is the data I'm using for this. It's quantitative. no context for this. And on the left side of the line, we have our stem. And on the right side, we have our leaf. And what we have is the stem will represent all of the digits of each data value except for the very last one. So a better way, I guess, to think about it is the leaf is the ones place of each data value, and the stem will represent the tens place, the hundreds place, as far up as it goes. And what we do is on the left, the stem, we'll just draw all the values that we see, all the different values that are located in the data. And on the right side, we'll write each individual one. So let me kind of get this started to give you a better visual. So in this data, I took numbers from 1 to 39, random numbers, and we don't go past 40, so there's no hundreds place. We don't have to worry about that. So our stem will only include the tens place. And so we see we have some single digit numbers, 10s, 20s, 30s. And so our stem will be the tens place, which will be either 0, 1, 2, or 3 for all the values, because we don't have anything bigger than 34 in this data set. And now the leaf is where we go and look at each value and put it in order from smallest to largest. So starting here, we see our smallest value in this data set is actually 1. And so that is the leaf of that data point. And so we draw it in the leaf. Stem 0, leaf 1, 1. Now, we also have a value where the stem is 0 and the leaf is 2. And that is the next smallest value, so we'll separate it by a comma so we know it's a separate data point from the 1, and keep going. Here we see we also have a 3 as well as a 5, 6, 7, and 8. So we'll draw all of those in. Sometimes you'll see stem and leaf plots drawn without the comma. It's a matter of preference. So now we have all those. We can move to our 1 stem, and this will represent all the data values ranging from 10 to 19, because those will be the values that have a stem of 1. And here we see it looks like there is only a 12 and a 19. So we would represent the 12 by putting a 2 here, followed by the 9, as it's 19 is bigger than 12. And that looks like that's all we have for that one. And then for the 2 stem, it looks like we have a 20, and then a 21, a 22, a 24, and is that it? And a 25, and a 23. So that is my bad. 23, a 24, and a 25. And then lastly, for the 3 stem, we have a 30, a 32, and a 34. So we'll have a 0, followed by a 2, followed by a 4. And just like with the bar chart, a good way to check afterwards is to count the number of data points you have and compare it to how many leaves, I guess, you have. So it looks like we have 7 plus 2 plus 6 plus 3, which is 18 on the left here in our stem and leaf plot. And on the right, I'm just going to count really fast. It looks like we do also have 18 data values, so it looks like we did not miss any here. And what you'll see later is we can actually use this stem and leaf plot to determine the distribution of what the data values actually look like overall. That will be in a later video. And so that's about it for this video, but not all for visualization. Next time I'll introduce relative frequency and cumulative frequency, and we'll need those two concepts to kind of see just a couple more graphs and tables, such as the Pareto diagram. And then we'll also look at some ways that graphs and tables should be drawn appropriately. There's a lot of ways that they can be made so as to deceive the viewer or the reader. And we're going to show some kind of good etiquette in making tables and graphs. So that's it. I'll see you in the next video.